Hello guys, and welcome to the part number 51 of the Node Editor tutorial series. My name is Pavel Křupela from blenderfreak.com, and today in this part we are going to implement this feature. So once I create the node and start dragging an edge, then I can right click, select a different node, and it will automatically connect. So let's start coding. We should do that in the calculator sub-window, since at the bottom here we are handling new node context menu, which is here, and we are creating the new calc node, setting the scene position, and also printing something like selected node, debug statement, etc. However, as a next thing, we should definitely store that to the history. So that means that would be called by self scene.history.store history, like this, and we can say created %s and pass in the new calc node underscore class name, like this. Perfect. However, just to be sure, let's go to the scene history and enable the debug for now. Perfect. And now we can try to detect if we are actually currently dragging an edge. So we can do that really easily, since we in the scene got the view. So get view, and we got something like a mode, because if you remember, we implemented in the node graphic view something like a state machine containing mode with the constants. In our case it's mode edge drag, and we do need to import that. So let me just quickly from node editor dot node graphic view import mode edge drag. Perfect. And this is true only when the mode is dragging edge. So let's try to have a look how we implemented that. Actually, we do got the business logic here on the mouse move event. So we are detecting mode edge cut, drag, etc. and this works perfectly fine. Once we release mouse button, which should be here, mouse release button, and the mode was mode edge drag, then we are checking if the distance is being too far. However, if we want to end the dragging edge, we implemented everything into the edge drag end method. This is this one. It resets the mode and does a bunch of stuff. It's getting the item, and in this case we are checking if the item is the QDM graphic socket, and if it is, then we actually connect or create a new edge with the correct socket. So therefore, since everything is already implemented and it's on one single place in one single function, now you can see how important it is to keep the architecture clean as possible. We can just basically go here to the calculator sub-window and just call self.scene.getView edge drag end, and pass in new calc node and access the input, the first one, and pass in the graphical socket. And this is everything, literally everything we need to do to be able to create dragging edge, right mouse button click and select the node, and it gets immediately connected, which is completely perfect. However, let's check out our console here. We got initial history stamp, created input, and the next thing we stored into history was just output. And if I remember correctly, the output hasn't been selected, which isn't nice. So we can change it a little bit or add some code, and the graphical node can be selected really simple with new calc node dot gr node set selected true. and this is telling the Qt5 that it should be selected and also to be drawn selected. However, in our case of the node graphic node, which is here, we do have the paint method here. Let me find it. Right here, mouse release event. We are using the last selected state, and we are also calling our own callback called onSelected. And this logic isn't being connected here nor put out for the user to use. So we should replicate these callings also in our calculator subwindow. So therefore, new calc node dot gr node dot last selected state equals to true, and the new calc node dot gr node and call onSelected. Let's have a look what this is doing. And here it is calling self, scene, graphical scene, item selected, and there is a bunch of logic around this selection and deselection, which actually automatically stores the history of selected items. So therefore I'm just going to write else, because we want to store in the history just the case that we created the edge without dragging. So if we run it now, let's have a look. Input, drag a new edge and create output, and it is selected. As you can see, we got 3 steps here: initial history stamp, created node input, and here is created new edge by dragging, and selection changed. Perfect. So if I deselect everything, we are on the step number 4. Now it's selected, deselected, deleted, and the input can be removed also. When I do redo, we created input, then we created output with a dragging edge, then we selected it, and then we deselected it. So this is now working, which is perfect. Probably we should also evaluate the node when we create it from the restore history stamp. So first of all, let's have a look here, and we can write a comment here. So if we were dragging an edge, and instead of calling these 3 functions here, we should be able to call something like new calc node dot do select and pass in true. This way it will be much more clearer for the user how to do the selection, instead of writing all of these 3 lines and find out that he needs to set up, when he is working with the node, that he needs to actually set up graphical node and call some set selected, and that actually the set selected is not good enough. He needs to just say even the last selected state and call in our callback. So therefore, let's create a new kind of functions or methods in our classes, which are starting with do or handle, which can take care about these operations and also about the low level operations like these 3 here. So I'm going to cut these now, and let's go to the node graphic node. Here we got onSelected, so underneath that let's create define do select self and new state, which by default is going to be true, and paste all the 3 lines here. Now we can say self.setSelected also here, and this way we are going to select it. But instead of just calling the true here, let's pass in the new state like this, and do call the onSelected only if the new selected state is true. This is perfect, and this is in our graphics node. So let's go ahead to the node, which is here. And here we go, we got the init sockets methods and the on, and just below the on we can pass the do select with the new state again. By default that's going to be true, and in this case we can call self.grnode.do select and pass in the new state, just like this. The same thing we will copy into the edge. So let's go ahead here. Here we do have the get other socket. Underneath we can say do select. In this case it's going to be self graphic edge. The magic function here, I would like to move it just below like this, because I want these functions to be one of the first in our class, and we should probably write everything into the coding standard guideline or something, which will definitely go into our documentation. However, first of all, let's finish this one. I'm going to copy the do select here and go to the node graphic edge. Perfect. So let's paste it here, just like that. Go ahead to the calc sub window and let's try if it actually works, if it did break something. So it looks like this node is selected. That's perfect. And to be able to select our edge and call do select on the edge, we can go to the new calc node and go to the inputs and to the first one, because this is the socket where we are actually connecting the drag edge here, but I guess we are not returning the newly created edge, so we need somehow to access it. And we do have edges as a list inside of our socket, and basically we are appending edges to this list. So in Python there is also something we can say -1, and that means the last index in the list, and this way we can access the last edge, which is the edge we just appended, and on that edge we can do select with true. So let's test that one. Perfect, and the edge is being selected. However, by default I don't want this, so I'm going to comment it, and we can leave the rest as it is. And let's do the other thing we were talking about and go ahead to the documentation, which is the dots, and in the source we can create a new file which is going to be called coding standards.md for the markdown language, because I like to use the markdown. So first of all, this is how we write a header with the hashtag, so coding standards. This way you can write subheader, and this is the way how you can write a list. So for example, files in a node editor package start with node underscore. And as you can see, PyCharm is so awesome that it actually shows you how the markdown language would look like with the HTML. So for example, if you want to use a code, you can write these 3 signs here at the end and at the beginning, and it will look like a code. So let me just go ahead and write all of the coding standards, and then we can talk about them. So these are basically the all coding standards we were talking about when we were writing or creating these classes throughout the tutorial. Most of them are already familiar to you. However, for the new people, it will be much easier to read something in the documentation like this, just to be able to get some kind of a sense for the orientation in the code. So we do know that we are using the convention that all of our files start with node underscore something. The node graphics contain the PyQt5 overridden classes, which represent the graphical stuff inside of our node editor. And then here is our coding guidelines. We do use camel case naming for the methods and the snake case naming for the values and properties. However, according to the PEP, you should be able, or you should be basically using just the snake case naming. I don't like it so much to write all the functions with snake case. However, it's completely on you. It depends on you which coding guidelines you are going to use. Just use them. Just please have some and try to document them so everybody else who is going to work with you will get some kind of an understanding about your thinking at least. So just to go ahead, we do want to have in the constructor always all of the properties initialized, so anybody can have a look at the class in its init constructor and see with which kind of properties we are working in the class. No surprises later. Then we are using the listeners and our custom callbacks, so just provide add something listener classes. Also we do have the do methods, on methods. These are for the events, these are for some basic operations, and our class usually follows this kind of rules. So the ordering of the methods in the class is the first one should definitely be the constructor, and then the init functions will follow. In the case we are using our custom events or listeners, just provide the listeners, node editor event functions. Then we are trying to keep the do and get helping functions here. After that we are overriding the Qt5 events, and then the magic methods, other functions, and at the end there should be paint method if we are using one, for example in the graphic edge node and stuff like that. And as the last one there should be serialize and deserialize methods just at the end of the file. And the last thing to change is, or to fix, is when we do undo, for example. As you can see, our node is not being evaluated, so let's go ahead and fix that. It would be really nice to go to the scene history, which is here, and here we already have something like history modified listeners, and it would be nice to be able to append our callbacks even when we restore history only or store the history only, because anyways anytime when we do undo or redo we actually do restore history, so therefore we can go ahead and in the callback we can re-evaluate all of the output nodes if we do that. So for now let's go up here and let's write a comment, listeners. I'm going to copy these 2 times because this is going to be history modified, history stored, and history restored listeners, like this. Perfect. In our coding standards we said something about add history listener functions, that they should be somewhere up here. So let's try to move them. Again, I'm going to duplicate this again, copy the stored history and restored history, history restored, and history stored listener, like this. Perfect. Now when we restore history for callback in self._history restored listeners, call in the callback. So we are calling twice, once the modified listeners and second one is the restored listeners. Okay, and the store history, same thing for callback in self._history stored listeners, call in the callback. just like that. And in our calculator subwindow at the top, we do append to the add has been modified listener. We can also append to the history. So self.scene.history.add history restored listener. And in this case, we will call self.on history restored. And what's going to happen when the history is being restored? Basically the same thing like when we load up the file. So this is exactly this code. We go through each of the nodes in the scene, and if it's output node, we are trying to evaluate it. So instead of writing it in this 3 or 4 lines, let's create self.doEval outputs and paste it here. Define doEval outputs, just like that, and paste the code here. Great. And for this function, let's do it here. Define on history stored self.doEval outputs. Perfect. And now when you run it, we got input, output, and I do undo. You can see it is still 1 even when I do redo. So this is calculating perfectly. Great. So I thank you for watching and see you at the next part.